Hello. Here we go. Two basic differentiation rules. Next section up. Calc BC. Homework's to the right. It's quite a bit. Have fun. Shouldn't take you that long though. Find the derivative of a function using the constant rule, using the power rule, and then find the derivatives of sine and cosine. So we're going to start with some trigonometric functions in this section. Now, you do not have to use that limit definition of the derivative to find the derivative of a function because you guys know this. There's a shortcut. And let's, I guess, get to the shortcut pretty quick. So the derivative of a constant rule and a power rule, the derivative of a constant is 0. We already know that. So the slope of a constant, it must be 0. Okay? So if I have y equals 3, well, what's y equals 3? Y equals 3 is like this. Well, that's 0. The slope of that line is 0. Or if I say it's x equals 3, then that doesn't even exist. So we gotta think about that. Okay? So it has to be 0. It can't be anything else. The derivative of a function with x raised to a power, so f of x is equal to x to the n, is f prime of x is equal to nx to the n minus 1. So this n pops down in front, and then we just subtract 1 from whatever number's there. Pretty easy. You guys already know how to do this anyway. So the derivative of this is f prime of x is equal, we put the exponent in front, 5x, and then we drop this minus 1, so it's to the 4th power. Fantastic. This is f of x is equal to x to the negative 2. It's always easier, instead of having fractional, like rational fractions, to make sure you put negative exponents in there because it's just easier. So f prime of x is equal, you bring this number out front, negative 2x, and you subtract 1, which is negative 3. If you wanted to write this correctly, then you would say negative 2 over x to the 3rd power, which is equal to f prime, but that doesn't matter. That's okay. Number 3, this we need to know how to write that in exponential form, which is x to the 2/3. The root is the denominator, and then the power on the inside is your numerator. So take that. I want to find the derivative. So I bring this 2/3 to the front. I put x and I subtract 1, so that's now negative 1/3. So I can rewrite this as 2 over 3 to the 3 times the 3rd root of x. So this is just another way to write it. This would be acceptable as well. You don't have to worry about changing it. Okay? The constant multiple rule. If f is a differentiable function and c is a real number, then cf is also differentiable. So what that means is, if I have c times some function, so for instance, if I have 2 x to the 3rd power, I can split up the x to the 3rd, do that separately, which would be 3x squared, and then multiply all of that by 2 and get 6x squared, and that would be fine. You could definitely do that. That's okay. Alright, that's all it's saying. So in this case, I'm going to find the derivative. Bring the 2 down, multiply with that 3, I get 6x. Pretty simple. This one is really 2x to the negative 1 of f of x. Alright, so f prime of x is going to be negative 2x to the negative 2, because I got a minus 1 from that negative 1. This one, f of x is equal to 3x to the 3/5. So f prime is equal to, bring that down, so that's 9/5 x minus 1 to the negative 2/5. I'm going to leave it there, but you can put it into x roots again. That's fine. That's up to you. But it's going to be in your denominator, and it's the 5th root of x squared. But that's up to you. Okay, fantastic. Next stuff. Sum and difference. So basically what this is saying is, if you have two functions that are separated by a plus or minus, then you can separate your derivatives. Okay, so f prime, I can split them. So split and split. So I get 3x to the 2 plus 2x, and then because this is a constant, it goes away. This one here, I'm going to rewrite this as x to the negative 1. So I get f prime of x is equal to 15x to the 4 minus 6x squared minus x to the negative 2. Because this minus comes down as a new negative in front of that value. So we got to watch for that, okay? Watch for that. Alright, here's some trig. I know you guys were like holding your breath and make sure we would get to it in this section. We are. My throat's parched again, but I don't have any more soda. Maybe I should find some water or something at 1:30 in the morning. Alright. Derivative of sine and cosine. So we probably already remember derivative of sine is just straight up cosine. And then derivative of cosine is negative sine. I'm not going to spend 20 more minutes explaining to you why it is. Just memorize it, and that's all you need. Okay? Now, this is the same thing as before. F prime, I take the derivative of sine and I multiply it by 2. So that's 2 cosine x. This one here, f prime is going to be 1/2 cosine x. And this one is going to be f prime is equal to 1, because the derivative of x is 1, minus a good old sine of x, because cosine of x, the derivative is negative sine. So there we go there, those three. Horizontal tangents. Horizontal tangent lines have many applications in calculus. You can find where a function has a horizontal tangent line by taking the derivative of the function and setting it equal to 0. So, for what values of x do the following functions have a horizontal tangent line? Horizontal meaning this way, not vertical, okay? So in this case, I'm going to take the derivative, so f prime is equal to 6x minus 2. I'm going to take that then and set it equal to 0. And I'm going to solve. I'm not going to do much of the work, and that's 1/3. So x is equal to 1/3. So that means at the value x is equal to 1/3, there is a horizontal tangent line. F of x is equal to negative cosine. So that means f prime of x is equal to negative times negative sine, which is equal to just positive sine x. When does that equal 0? Well, if we remember from our unit circle, sine of x equals 0 at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So I'm going to say x is equal to 0, pi, 2 pi, 3 pi, dot, dot, dot. And that's it. I don't think there's anything more. I'm going to scroll down just in case, but I don't think, nope, that's it. See? Not too bad. It's a pretty fast video. Alright, that's section 2.2 out of the way. I'll see you in the next one. Deuces.